right, guys, we're on the back side of day 7 notes. And in number 3, it says that PA equals 3. So from P to A, that length there is 3. PB is 8. So from P to B, I recommend using a bracket because it's the length of the hole. Okay, so that's 8. And then they tell us CD is 2 less than PC. So what we're going to do is we're going to call PC X. And it says that CD is 2 less than PC. So CD is going to be X minus 2. All right. So because this has to deal with lengths and not angles, and it's 2 secant, so we're going to remember the formula is the whole times the outside equals the whole times the outside. So if we abbreviate it like that, it looks like WOWO, right? Wow, or OO, or whoa. You can remember it however you want. All right. So what we're going to do is we're going to look at the top secant. Okay. And so the top secant, let's just highlight it so you guys can see it better, is this one. And the whole thing is bracketed, and the length of the hole is 8. So we're going to go ahead and replace the hole with an 8. Then we need the outside part of that highlighted secant. And you guys can see the outside part, the part that's outside has a length of 3. And so we're going to replace the outside part with 3. Okay. If we go ahead and I'm going to highlight our other secant in green, and we need the whole length of that. And that one's going to be a little bit tricky because we don't have that whole length. So if we go ahead and bracket it, and remember to get the whole, we take the 2 parts and we add them together. X minus 2 plus X. This X plus this X will make 2X, and then the minus 2. And so we're going to go ahead and use that expression for the whole. So we're going to take out the whole here and replace it with 2X minus 2 times the outside part, which you guys can see the part of that green highlighted secant. The outside part is X. All right, so now that we have a substance, now we just use our algebra. Okay, 8 times 3 is 24. Equal to, over here, guys, we're going to have to do a little distributing, almost like backwards. We have 2x times x, which is 2x squared. And then we have x times negative 2, which is negative 2x. And you guys can see we have another quadratic forming here. We have that squared term. And we're going to have to factor to find our 2 answers. And we can't factor unless we're equal to 0. And so we're going to bring this 24 over. That way our x squared term stays positive. And we're now equal to 0. Okay. We're not used to having this 2 here, but that's okay. We can get rid of it by factoring it out. So we're going to take the 2 out of every term. It's called the greatest common factor. And we'll be left with an x squared minus x minus 12 equal to 0. And now you can see we have our nice easy trinomial inside our parentheses. And so we're going to multiply to negative 12. And at the same time, we're going to add to negative 1. And the numbers that are going to do the job are 4 and 3, except our 4 has to be negative so that they add together to give me negative 1, and that they multiply to give me negative 12. Okay, so this 2 kind of really stays here, and then the trinomial gets factored into x minus 4 and x plus 3 equal to 0. Okay, this 2 technically gets set equal to 0, but there's no x in there to solve and give us a solution. But with this factor here, that factor would give us a solution of x equals 4. And this factor here would give us a solution of x equals negative 3. And because we're talking about lengths, there's no way that PC, which represents x, can have a length of negative 3. So we're going to go ahead and reject that one. And we're going to keep x equals 4. Okay? And therefore, if PC equals 4, we have our answer. Okay? Good, guys. That's a tough question. All right, so let's see if number 4 is any easier. Okay. So in 4, it says find PC. And so we're going to go ahead and put an X on PC. And realize that this problem is also talking about the lengths of our tangents and secants. And so we're going to go ahead and say whole times outside equals whole times outside. All right. We'll go ahead and highlight our first segment. and that's a secant. And the whole length of that secant would be represented by part plus part, 9 plus 3, which is 12. So we'll take out the whole and replace it with 12. The outside part, you guys can see the part of the secant that's outside the circle is 3. So we'll replace the outside with 3. And now we're going to go to our other line segment, which is a tangent. Okay? And the length of that whole tangent is x. So we're going to replace the whole with x. And then we'll replace the outside. Well, remember, a whole tangent is outside. So the whole and the outside for a tangent actually ends up being the same substitution, okay, which is x. All right, we'll go ahead and multiply. 12 times 3 is 36, equal to x times x, which is x squared. We'll take the square root, and we end up with x equals 6. Okay? And therefore, PC equals 6. All right, that one was a lot easier than number 3. Okay, so depends on what they give you. Depends on the level of the difficulty of the question. Okay. Number 5, it says secant ADC and tangent AB are drawn a circle O from external point A. So we're going to go ahead and draw our circle. And it says that we have a secant. So I'm going to go ahead and draw a secant and a tangent. Okay. And notice that they have the same letter A in common. And they also told you it was from external point A. And so I'm going to label this point here on the tangent B so that we have tangent AB. And secant, this will be the D, and this will be the C, so that's secant ADC. Okay, they're going to tell us that AB is 12 and that AD is 6, and they want you to find the length of AC. So I'm going to bracket A to C and call that X. All right. Again, this has to deal with lengths of tangents and secants, and so the formula is whole times outside equals whole times outside. All right. So I'll highlight our first one. This is a secant, and the whole secant is represented by X. So we're going to replace whole with X. The outside part of that secant is 6. So we'll replace the outside with 6. Okay. I'm going to highlight my tangent so that we can do the other half of our equation. And the whole thing, because it's a tangent, is 12. And therefore, so is the outside part. Okay. And if we do our algebra, x times 6 is 6x. 12 times 12 is 144. If we divide both sides by 6, we're going to come out with x equals 24. And therefore, AC equals 24. Okay. Okay, guys. Number 6. It says in circle O, chords AB and CD intersect at E. So we have a chord called AB. We have a chord called CD, and they intersect at E. Okay? And it says if AE equals 6, and BE equals 12, and CE equals 8, they want you to find what CD measures. So in this one, I'm not going to call CD X. I'm actually going to call this piece X, because I know the formula for two chords is part times part equals part times part. And these two parts are from the same chord. And so I'm going to go ahead and replace this part with 6. And therefore the other part of the chord is 12. Equal to, on my one chord, I have one part that's 8. And on that same chord, the other part is X. Okay. 6 times 12, guys, is 72. And 8 times X is 8X. And I'm going to divide by 8, and X comes out to equal 9. However, don't be tempted to pick the 9. This is 9, which is ED, and they want CD. CD is 8 plus 9, which is 17. And so our answer is actually choice 3, which you might have picked choice 2. So be careful on a multiple choice question because there's no partial credit. Okay. Number 7, it says in a circle, we have a chord of 30 centimeters bisects a chord of 18 centimeters. All right, so hold on. We have a chord of 30 centimeters bisects. Bisects means to cut in half. Cuts in half a chord of 18 centimeters. So you know what I'm going to do? I'm going to go ahead and use this one here as the chord that got bisected. And so bisect means to cut in half. So I'm going to label 9 and 9. It says the length of the shorter segment of a 30 centimeter chord is what? And so on this one, this piece here looks like the smaller piece. So I'm going to call that X. And because this entire chord is a length of 30, I'm going to call this 30 minus X. We did that on one of the questions in the front, okay? And so now that I have my parts, remember the formula is part times part equals part times part. My one chord has 2 parts of 9, so 9 times 9. My other chord has 1 part X and the other part 30 minus X. 9 times 9 is 81. And here, X times 30 is 30X. And X times negative X is negative X squared. Okay. You guys can see this is going to turn into a quadratic or a trinomial, except our X squared is negative, and that makes our factoring harder to get our 2 answers. And so we'll add the X squared over, and we'll subtract the 30X over. And that way I have X squared minus 30X plus 81 equals 0. Now we're going to go ahead and do our X box. Our multiply is 81, and our add is negative 30. And when you find the numbers, you're going to find that they're 27 and 3, but in order to give you a negative 30, both of them have to be negative, and then that helps us multiply to the positive 81. Okay. Now we can go back and factor. So our factor will be X minus 27 and X minus 3. Okay. And then X will equal 27 and X will equal positive 3. And now we have to go back up and answer the question. It says that the length of the shorter segment of the 30 centimeter chord is what? So if this here is 27, then 30 minus 27 would be 3. Okay. So the length of the shorter segment of the 30 centimeter chord, the shorter one, would be 3. Okay. Now, if you used your answer of 3, okay, and this was 3, and 30 minus 3 is 27, you still end up with the shorter segment being 3. Okay. All right. One last question, guys. Number 8 says in the diagram below of circle O, chords RT and QS intersect at M, and secant PTR and tangent PS are drawn to circle O. The length of RM is 2 more than the length of TM. All right, so for TM, we're going to call that piece X. And 2 more would be X plus 2. And then they also tell us that QM is 2. And that SM is 12. And then they go on and tell us that PT is 8. And they want us to find the length of RT. Okay. And they want us to find the length of PS. Okay, so let's go with one at a time. So what it looks like in this question they're doing is they're putting part times part equals part times part, and whole times outside equals whole times outside. All right, because we have chords in the circle, but then we also have tangent and secant outside the circle there. So we're going to go ahead and make sure we organize our work, okay? So for the first one, we're going to go ahead and do the chords on the inside of the circle. So for the chords, remember the formula is part times part equals part times part. And so looking inside my circle here, I see one chord that has 2 parts of 2 and 12. So I'll use that one first. So this will be 2, this will be 12. And the other chord we called one x and the other x plus 2. Okay. So now that we have all that information entered in, we'll just follow our algebra. 2 times 12 is 24. Equal to x times x, which is x squared. And then x times 2 is positive 2x. It's going to turn into a trinomial. So we're going to bring over the 24 by subtracting it. And now we can go ahead and set up our x box. A multiply of negative 24 and an add of 2 ends up being the numbers, let's think, 24. How about we use 6 and 4 and make the 4 negative, so that'll multiply to negative 24 and it'll add to a positive 2. Okay, so we'll do our factoring of x plus 6 and x minus 4, and we're equal to 0. And then we'll end up with x equals negative 6 and x equals positive 4. Okay, and so now we got to remember what we are doing. All right, so remember the first question guys asked for the length of RT. I think we can now find the length of RT. So remember that x can't be negative 6, and so we'll reject this one. Okay. But if we go ahead and we put in our 4 for x, MT ends up being 4, and RM is 4 plus 2, which ends up being 6. And so now I can answer the question that RT is going to have a length of 6 plus 4, which is 10. Okay. All right, so on to the second question they asked. They asked us to find the length of PS. So now that I don't have an x anymore because I solved for it, I can either use x again or I can use y. It's completely up to you. It might make a little bit more sense when you look at my work to use a different variable, okay? So I'll use y. Well, y is a tangent, okay? And we also have a secant, and so we're going to follow the formula of whole times outside equals whole times outside, okay? And so we'll look at the secant first to figure out the whole and the outside, okay? All right, so we're going to have to be very careful with what we have here for the whole, all right? So it looks like we have 6 here, 4 here, and 8 here, all right? And so 6 plus 4 plus 8 gives us a whole of 18. All right, the outside part of the secant that's outside is labeled as 8. All right, on the other side, because it's a tangent, remember that the whole tangent is outside, so the whole and the outside end up being exactly the same. And so we call that both y, because that's what we're solving for. So we'll say y for the whole and y for the outside part. Okay. All right, we'll follow our math. 18 times 8 is 144, and y times y is y squared. We'll take the square root, and y comes out to equal 12. This one was a lot easier to solve, okay? And therefore, PS is what we called y, and y is 12, so PS is 12. And this one's finished. All right, guys, I will see you on the next day of notes.